Okay, so picking up where we left off, I have already started the problem. We're just going to do the math now. You're going to do 4,000,3152 and push enter. Make sure that you do this step first, because if you divide, it's not going to do it in the correct order. Then you divide that answer by 693, and you obtain 1.22. Okay, so that's the z-score. And then if we do it again for the other one, 99 minus 98.2 divided by 0.62, 1.29 is your z-score. And then if you look at the number line, here's 0, here's the baby score, here's 1, and here is the adult score. So obviously 1.29 and 1.22. Okay, obviously that indicates that the more extreme value here is the adult temperature. Okay, and I don't know what I did. Hold on, what is this thing doing? Oh, there we go. So in general, in interpreting significant values of a z-score, in general, any data that falls within 2 standard deviations to the left or right is considered normal. So that means any numbers between -2 and 2 are considered not significant, while significantly low values and significantly high values are found at 2.5, 2.6, 3.0, 8.8, and -3.0, and -3, and 2, and -2.5, and things like that, not 2. So if it's normal, it's in the center. If it's abnormal, it's on the outsides. Some important properties of z-scores are: a z-score is the number of standard deviations above that a given value x is above or below the mean. Z-scores are expressed as numbers with no units of measurement. If an individual data value is less than the mean, its corresponding z-score is a negative value. And use 2 decimal places for these, because that's how they'll be found if you were to use a table. If we're going to talk about percentiles, the kth percentile, denoted p sub k, of a set of data is such that k% of observations are less than or equal to the value. This means percentiles are divided into 100 percentages. Jennifer just received her results of her SAT exam. Her SAT mathematics score is 600, is in the 74th percentile. Since she's in the 74th percentile, this means 74% of people scored less than or equal to her, while the remaining 26 of students scored higher than she did. If we have quartiles are just when you break the 100% into quarters. So P25, P50, and P75 are the 3 quartiles, Q1, Q2, and Q3. This is done the same as the median. In fact, Q2 is the median of the data. So the other Qs are found by breaking the data into 2 separate pieces where the median is at Q2, and then finding the median of the subsets of data. So if we were going to do this, I wonder if I did this. The Highway Loss Institute routinely collects data on collision coverage claims. Collision coverage ensures against physical damage to an insured individual's vehicle. To the data in tables 16, 18 collision coverage claims based on the data obtained from the Highway Loss Data Institute. Find and interpret the first 3 quartiles of the collision coverage claims. So, sorry, that was horrible reading. The data is written in ascending order, given as follows. So they put them in order for you. They've broken them into quartiles. If you look on the far right, 1657 and 1953 is where this thing ends. I believe there's an even amount, yeah, because they're in 2s. And so the median is Q2. So remember, you're going to add 1. There's, I believe, 18, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, there are 18. So 9. So 18 divided by 2 is 9. So 1657 and 1953. If you average that, you'll get the value for the Q2. And then if we look on the top line, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. The one in the middle is the Q1, so that I believe is 735. And then right below that is the Q3, which is 4,668. The calculator tells you quartiles as well. So if you do all that standard, the same thing we've been doing with the 1var stats, if you do that on the calculator, if you scroll down, you'll see where median is. Right above it, you'll see Q1, and right below it, you'll see Q2. And then an outlier is a upstream observation that is outside what we consider normal. For instance, like when we added the 99999 to the data set earlier in the other videos, that would be an extreme outlier because the interquartile range is Q3 minus Q1. So if your data Q3 is 6 and your Q1 is 2, 6 minus 2 is 4. And then if you do Q1 minus 1.5 times 4, which is 6, then everything should fall within that range. And if it's outside of that, then it's called an outlier. So you just basically calculate this IQR, and then you check if it's an outlier, which we'll do right now. So we have this data. The 1805 obviously came from the average of 1657 and 1953. So let's do this real quick. We have Q1. Oops, that's ugly. Q1 735. Q2 is 1805. Q3 is 4668. And then it says determine IQR. Well, you're just going to do Q3 minus Q1. So, oops, sorry. Click the wrong thing. So we do 4688. No. 4668. Minus 735. Go away. And that's equal to 3933. This is our IQR, interquartile range. Oops, that's like horrible. What am I doing? I, Q, and R. Okay. So now we want to figure out what the interquartile range is. So all we're going to do is we're going to take Q1, 735. We're going to subtract 1.5 times 3933. And that's going to give us 735 minus 1.5 times 3933. Negative 5164.5. Okay, so that is our lower boundary for it. If we want our upper boundary, we're going to do 4668 plus 1.5 times 3933. 4668 plus 1.5 times 3933. That's 10,567.5. And so what this says is in order for a number to be an outlier, it needs to be outside of that boundary from negative 5,164.5 to 10,567.5. And with that being said, if I was to give you 200,000 in that data group, then since that is on this side of this boundary, that would be considered an outlier for that data set. And then the other things would be considered, anything in between those would be considered normal, and then anything on the left of negative 5,164.5 would be also an outlier. I hope this helps, guys. Make sure you're watching the videos. The review's coming up. Make sure you study for the test. We're going to keep going. Thank you guys for watching.